Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Hello and welcome to another episode of the Chai Time Data Science Show. In this episode, I am really honored to be interviewing one of the best and most active current Kaggle competitors, Dr. Philipp Singer. Philipp is a senior data scientist at UNIQA Insurance Group, and he has obtained a PhD in computer science. He's been a distinguished researcher and, of course, a distinguished Kaggler. His research endeavors include several scientific honors, including Best Paper Award at the renowned World Wide Web Conference. In this interview, we talk all about his journey into Kaggle and data science, broadly speaking. Philipp has received medals in all of the competitions that he's entered, including 4 gold and 1 silver of all the 5 competitions that he's entered. So we, of course, talk all about his journey into Kaggle, his approach to competition, approach when teaming up, and the distribution of efforts in a team, his Kaggle journey, what competitions interest him, and how he approaches any competition in general. We also talk about his recent gold finish on the IEEE-CIS fraud detection competition, where his team titled The Zoo landed another gold medal, and we discuss all about the solution. I'd like to thank everyone who submitted the questions via the AMA section, and of course to Philipp, who agreed to the AMA section. For now, here's my interview all about Philipp's journey into data science, Kaggle, and his Kaggle experience. Please enjoy the show. I'm really excited to have Dr. Philipp Singer on the Chai Time Data Science Show. Thank you so much for doing this interview, and especially the AMA section.
Thank you for inviting me. I'm glad to be here and hope I can answer some questions.
You hold a PhD in computer science and have, if I may, a traditional computer science academic background. Could you tell us how did data science start to come into the picture for you, and how did you get started with data science?
I studied traditional computer science. It is rather called, the studies was exactly called software engineering and economics. So it was kind of a bit of a mix of computer science and some economics classes, but was heavily focused on computing science. I studied in Austria, and I did a bachelor's and a master's program, basically. And in our master's program, we could kind of choose between a few different topics. At that point in time, data science was not a term yet, I guess. So it was rather like, there was some stuff in the area of like a little bit of artificial intelligence, a little bit of, I don't know, data mining and those areas. So there were a few courses which I attended.
This was around 2010, if I got that.
Yeah, exactly. It was around that time. And then I attended a few courses from one of the professors there. And it was in the area of data mining and what you would nowadays call data science. And then I did a few projects. I did the master's thesis in that area. In my master's thesis, I studied some data on Twitter. So I was like crawling Twitter through API, analyzing some topical things there, and so forth. And that's a bit how I got into it, I would say.
Okay.
Yeah.
Got it.
It was kind of like the institute was called knowledge engineering, or however you want to call it. And then from there on, I decided to do a PhD at that institute, and that kind of is when also the whole field kind of exploded a bit, and I got into the field.
Got it. You're currently working as a senior data scientist at the UNIQA insurance group. Could you tell us more about the problems you're working off Kaggle, and what does a day in your life currently look like?
Yeah, around 2.5 years ago, I started working as a data scientist there. It's a very large, it's basically the largest insurance company in Austria. There are a lot of also outside things in Eastern Europe. So it's kind of also spread across Europe. I mean, maybe to give a bit of background, how it is in that field in Europe and specifically Austria, like you cannot compare it to anything that is in the US or that is in London or wherever. Like, so it's very slow, and companies just try to get into the field, I would say.
Okay.
So it's kind of hip and nice to have a data science team and to do something with machine learning, artificial intelligence. There is, as everywhere, there are a lot of consultants running around doing these things. I think we all know that. Yeah. So we are a very small data science team. Basically, we have three data scientists. Dimitri Dot, who is called Dot on Kaggle, is also my colleague. I'm always collaborating with him on Kaggle as well.
Okay.
And what we try to do is basically enable the business units within the company to do some more sophisticated stuff with data that enables them to do some better business decision making and also improve the processes internally and externally. So that means we need to talk a lot with business units. We need to talk a lot with them and try to figure out what kind of problems they're facing. And then we try to bring some value to them by basically implementing certain models, certain other tools around data, and then try to also put that into production. So even though we are only 3 people, we try to be an end-to-end stop shop for them. So that means starting from getting the requirements, implementing it, and also what we need to also do ourselves is like deploying the models and putting them into production. Because there are no processes around those things yet within the company. So that's what we try to do.
Got it. For reference for the audience, this usually is a multi-team task, and it involves multiple people from different teams working on different tasks most of the times.
Exactly. Yeah, and I mean, yeah, that's there are of course a lot of challenges you need to face, but at the same time you also have some kind of early adopters advantage, and you can also steer the strategy in that area a bit, which is also something nice. Right. And also you learn a lot of new stuff. You don't learn if you just do modeling or something like that, because data science in itself is like a very broad field, and that means it's not only about modeling, but it's a huge part, of course, but there are other things like putting things into production, talking with business units, and those things around it, which is also something where you can try to learn things if you try to do them.
Okay. And all of these tasks, again, are handled by the 3 members in the team.
Yeah, I mean, of course, there are IT departments and so on, but they are then rather responsible for example, let's say we develop a model, we develop some API around it, we deploy that API, and then what they just need to do is that they call this API from the front-end systems or something like that. This is not something we can do, but everything before that and is something we try to do, and that's where a lot of work needs to go into. Yeah,
got it.
And the nice thing is, that we don't have any kind of topical focus. So we also try to work with different types of topics. So in an insurance, you can think about automated claim management, you can think about pricing, you can think about risk management. So we try to also diversify there a bit.
That's really interesting. Now, talking more about your research path, you took up a CS as a career path, and you were a renowned researcher in that. For the audience, I'd like to mention that you have multiple research papers, including award from the best as the best paper of worldwide conference. Could you tell us more about why you chose to initially take up the research path, and did once you found data science, did you start
Mhm.
finding any parallels between research and data science?
Mhm. Yeah, as I said, I kind of started to like it at the end of my master's, and then it was kind of natural for me because I had a really, really good supervisor in my master's thesis, and a really good mentor in him, basically. And then he offered me to do a PhD, which was for me kind of a natural transition then.
Okay.
And in the PhD, I learned really a lot of things, maybe even more than during my studies, I would say.
Okay.
So research in itself is like you learn a lot of things outside of hardcore programming, hardcore modeling, like how to approach a problem, how to do experiments, how to think critically about things, how to also criticize your own work, how to never be satisfied with something, which are all, I think, kind of important things.
Yeah.
So, and also writing papers, communicating the work. I mean, in research, it's very, very important that you also communicate your work. So you're not doing it for yourself. You're not doing it for your business or whatever. You always need to convince others that this is something that is valuable.
Right.
Which is also something where I learned a lot. Of course, it also has a lot of downsides, like you write a paper for months and then it gets rejected, then you need to do it. And it's also no easy thing. Some people get really frustrated, but I was really lucky that I chose a few topics which kind of fit. Then I had my best paper award, which kind of also was a boost towards the end. I had a really good supervisor, so it's not always as nice as I had it, I guess.
Mm-hmm.
But it worked out for me. Then it was kind of the decision for me to not proceed in academia. So the next step would have been to go into assistant professorship, to apply for grants more and for something. So I did a short postdoc, and then it would have been the decision to either continue there. And then I decided I wanna try out something else, and I wanna try out to go into industry and have a little bit more impact with what I'm doing.
Okay.
So that was kind of the idea, because in research you develop a lot of things, and sometimes they never get used. Sometimes, it's hard. And my hope was that in industry, at least you can put some things into work and really bring value to people. That not always works out. That sometimes works out. It's still as in research a kind of tedious process.
Yeah.
But I guess it's another side of the coin, which is also nice. And I learned different things, as mentioned before.
On your website, you also mentioned that you offer mentoring and teaching services. Is that still the case, or?
I mean, I'm not actively doing that at the moment, but this is something I would like to do to some degree, because this is, for example, something I miss from academia, where I was also teaching at university, where I was also mentoring other PhD students, master students. This is something I really like to do, and which is something I would like to delve into again. So this is something I would be happy to do more in the future.
Okay, so for the audience, if you'd like to reach out to Philip, we'll have his website linked in the description. But you're also an indirect mentor on the Kaggle forums, which we'll just talk about. Before that, I have a question from the AMA section by Evgeny Vasilev. They're asking, given your experience both in academia and industry, which experience of both helped you achieve such track record with Kaggle competitions?
First, let me mention that Evgeny actually was a master's student I supervised in university. So that's, and we kind of connected on Kaggle again, which is also quite nice. I think from both sides you can learn things. In academia, as I mentioned before, you need to learn about how to experiment, how to be very precise in what you do, how to think critically about what others put out.
Yeah.
You also need to defend yourself a lot. Like if I present a paper at a conference, you get like 10 questions if like you have accounted for this assumption in this statistical method, and if this is really valid and allowed what you're doing. So this is not the case like in at least for me in industry. Like in industry, I need to convince people that it works and that it brings some value.
Yeah.
But how I exactly do it, at least in my company, I'm sure that's different in other companies. Like there are not that many people out there who can really judge what you're doing methodologically wise, because they are kind of more focused on a business. So if I can show them, oh, this model brings that kind of value, then they're satisfied. How I exactly do it, and if I have in my logistic regression accounted for all the statistical assumptions, is a different question. Yeah? So they don't care. So, I mean, that's kind of the two perspectives, but bringing them together and being also not always happy yourself and trying to understand the concepts and trying to put them together is, I think, something that can be valuable. So on Kaggle, I guess specifically from research, what helps me is how to do experiments, how to incrementally improve on what you have, and how to build hypotheses that you then try to evaluate. And hypothesis can be, oh, maybe if I add this to my model, it works. Yeah, and then just roll it out and test it and evaluate it.
Yeah.
And more from industry is like, what works, that works. Yeah, it sounds simple, but yeah, I mean on Kaggle, no one will judge me in the end. I mean, some people judge you how you do it, but if you win the prize and if you do whatever, you don't need to convince them that this method is valid and this would have made more sense. It's still something you should think about, but that's kind of a bit bringing those two things together.
Got it. Could you tell us more how you started on Kaggle and what made you sign up for your first competition, which had an amazing result that I'll just mention in the next question?
We at work, we kind of, due to the reasons mentioned before, we kind of focus a lot on the things around modeling. We still model, but also based on the things I just said, it's mostly you can stop when you have a nicely working light GBM model with certain features that has this kind of accuracy, everyone is happy. And it's not worth until you have kind of really the business need to improve on that. Okay. So in order for us to be a bit more on the state of the art area, we decided, oh, let's do some things on the side. Let's also research and try out things. And then we got the idea, because Dimitri was also already doing it before, to just start with some Kaggle competition. We have a lot of textual problems at work. So that's why it was natural for us to start with some NLP, which was the Quora competition. And we didn't have too much experience with deep learning, which was another thing. So it started out as us trying to learn something and starting to get in touch with other data sets outside of work that we can play around with, and then hopefully also transform those things to our work problems.
Got it.
Yeah, then we got kind of hooked. We started out doing really well, and then we won that competition, and from that point on, I guess we were addicted to it and kept doing it. So yeah.
For the audience, I'd like to mention you absolutely knocked it out of the park. So I actually wrote down the percentages to sound cool, but you have 100% medal success rate with 80% gold medals and 20% silver medals in all the competitions that you took part in. How? Yeah. And did you expect it to be such an easy experience, or any challenges that you faced while working?
I definitely did not expect it to be easy, and it's not easy. I mean, it's not like we spent 1-2 days and then the results are there. You need to dedicate still a lot of time, I think, to it. in order to be really on top. So that's what we mostly did for the competitions. I mean, I signed up to Kaggle 7 years ago or something like that.
Yeah.
I just did one random test submission, I guess, at my first competition, which I just signed up to test how it works, and then dropped it because I thought it's impossible to do well because there are all these great people, all these great Kagglers, all these people I look up to. And then we just started, and it worked
now
out.
You're one of them.
And now we do well. So I mean, maybe the message is just never be afraid to touch something, because even if you don't end up at the top, there are other things you can learn on Kaggle, and it's not only about winning.
Yeah.
Yeah.
How do you balance time spent on competitions with life and work?
Yeah, I mean, it's hard. I'm probably the wrong person to give good advice on that because it's very hard. I think my girlfriend is not the happiest person if I do a competition, but no, I mean, I have a full-time job, and that means I need to spend most of my time during the day working for some other problems. In my spare time, and also if it's something that can bring a bit of value to work, we can also spend a little bit of time at work, but mostly it's in spare time. Like now, Saturdays, Sundays, it's usually some Kaggling time. During the night. We try to optimize our approach more and more to need less time to spend on some tedious things, but rather like already know how to do them and hopefully benefit from that in future competitions. But it's not that trivial, because every competition is unique on its own.
Right.
Yeah. I think if you're a good data scientist, what we try to do is jump in the competitions later on. So not directly in the beginning, because a lot of things are shared on Kaggle. You can figure out a lot of things later on, and then don't spend that much time, because I'm not the person, if I start with it, I cannot stop. So I need to go on. We actually did a mistake now. We started this new NFL competition, and it goes on for 2 more months. So maybe we should have waited with that. Yeah, but I mean, it's so fun to compete on Kaggle, so it's hard for us to not do anything. But I'm open for advice in that, how to balance it better. But I think it's fine.
For beginners, do you advise jumping in later or starting during the initial days? Because that's when also some of the learning happens, in my opinion.
Yeah, I mean, it depends. I think there are two different ways of learning. One is to try to do stuff yourself and try to figure out yourself things, which is trying to be blind of what other people put out and try to figure things out yourself. I think this is very, very crucial. So don't always copy the public kernel and go from there. Sometimes really start from scratch, figure out your own pipeline that you try to use for setting up cross-validation, for doing the modeling, for doing some feature engineering, for doing explorative data analysis, and so on. So everyone should do that, I think. The other thing still is that we live in an information age, and there is so much information out there, and not making use of it is stupid. So you should also always try to read on the solutions of previous competitions. You should also always try to figure out when a hint on the discussion forums is important, because I think that's a very crucial part that a lot of top Kagglers can figure out quite quickly. Like someone posting something about, oh, this feature, I have found that this feature is important and maybe people should look into it. And most kind of ignore that, because and top Kagglers kind of can make the connection between that and what they should do. So that's another important part. And so also be involved during the competitions. If you should start out early or late, I guess it depends on how much time you have. I personally, until now, don't like to do too many competitions at the same time. Basically, we always only did one competition, kind of focus on that one.
Interesting.
Because then you have more focus on something and don't, I mean, but some top Kagglers try to do 4 or 5 competitions at the same time, which is apparently also a valid approach. Maybe we will go into that. I'm not sure at the moment.
Okay.
Yeah. So it's kind of, you can do both. I think both things are valuable.
Right.
And definitely try to learn what others say in the end and also during the competition.
Got it. In hindsight, after you started on Kaggle and achieving good results, maybe you learned a bit from Kaggle as well. How did this affect your professional life? Did you have any takeaways for your off Kaggle data science pipelines?
I mean, definitely in the area of modeling. I mean, we learned a lot in terms of specifically deep learning, also more about how to do hyperparameter tuning properly, how to do blending properly, how to do feature engineering some things properly. So definitely that transforms to my off Kaggle work.
Right.
So I mean, I learned on Kaggle how to use PyTorch. I learned on Kaggle how to use Keras. I learned on Kaggle how to use certain frameworks. All those things I can use now at work. And
okay,
yeah,
that's really interesting. Congratulations on another gold medal. I'm sure it's no surprise for you, but your team,
it was.
your team titled the Zoo just finished
Yeah.
6th on the IEEE-CIS fraud detection competition. Before we talk all about your solution, could you maybe help me set the stage by giving us an overview of the competition and what was the challenge here?
In this competition, it was about detecting fraud in credit card transactions. So you had structural data with credit card transactions marked as 0 or 1. 1 was fraud.
Okay.
And you need to predict whether a transaction is fraud.
Got it. Could you maybe tell us your first go-to steps, maybe broadly, and also for this competition when you got started, and how did you approach the problem?
In this competition, we actually started late. We started maybe 2-3 weeks before the end. So usually, I mean, most of the people will tell you that the most important thing is to get a baseline model. Think about in the beginning already some kind of cross-validation setup. So let's say you discuss a bit, you think, okay, maybe for this problem, we go to a 5-fold cross-validation with shuffle or with no shuffle, whatever. Then you set that up. You try to generate some simplistic features from the data, maybe just taking the data as it is. Usually in tabular data, it would be using some light GBM model with basic hyperparameters and getting a baseline out and then trying to improve from there. That's always what we try to do. Also, always one of us prepares a kernel for it. So we have a kernel that we can share and then have a code base that we can all work from and then go from there.
Got it. Could you maybe also describe your high-level approach and how does your machine learning workflow look like after you have the baselines set up?
Yeah, I mean, there are many things that play a role. First of all, is like trying to find appropriate features, trying to properly. I mean, a very important thing usually is to think about what are you actually trying to model and what is the objective you're trying to model in. In this case, it's easy because it was easy because it's area under the curve. You just have binary outcome. It's quite of trivial that you go to optimizing our yeah. Then, so you need to decide on that. Then you need to decide on the CV. Usually you need to think very critically about the CV setup because that's very important for you to do proper experimenting.
Yep.
You can start with one thing, but then you should also think about it during the competition. And sometimes we change our CV setup during competition if we figure out some problems with it along the way. And then we try to do different modeling. We usually start out with doing some light GBM modeling, specifically, of course, on structural data. But then we also try to do other models like neural networks, try out some cat boost, some logistic regression, whatever fits the problem.
Right.
And then we also have another pipeline that combines the models for blending and for stacking. So we try to not throw away any models that we fit during the competition, because sometimes even going back to some old models can be valuable.
Even the bad?
Yeah. So what we try to do is usually that we set up some either some cloud storage or something that all team members push their models to in a structured way. So we have kind of like a certain setup that you push your CV predictions there, you push your test predictions there, you push your accuracy of that model there. And then we have another script that kind of picks up everything and blends it together. So that's a nice workflow that we figured out, specifically if you work with others, because then you have one central storage that people push their models to, and then you can do easier blending and checking. And keeping the old models is also valuable, because sometimes you need to go back a few steps and try to pick up on them. And also specifically for blending and for stacking, sometimes having weaker models is also beneficial.
Yeah.
And so not throwing them away is, I think, at least at some point, it makes sense to not throw everything away.
Okay.
That's kind of the rough workflow. I mean, then it's very, very specific for each competition and also of which team members we have.
Yeah.
Yeah.
To talk a little bit more about CV, so CPMP, the Grandmaster of Discussion, mentions that if you have a good enough CV setup, you essentially get unlimited submissions in a way. Could you maybe share more CV tips, and how does a good CV for you look like?
I mean, a good CV in perfect case is something that has correlation with public leaderboard, because then you're experimenting, you can trust your CV at least for the public leaderboard.
Yeah.
So if your CV increases, your public leaderboard increases, it's perfect. I mean, you need to trust your CV. So you need to trust that it is not overstating something. So for example, if you have a leak between folds and your CV is overstating something and this doesn't translate to public leaderboard, you need to carefully think about it. So for example, in the previous fraud competition, you had certain things that, like, there was something about, we can talk about that later a bit, but there was something like user IDs. And then if you have in different folds, or the same user, you kind of overstate the CV in that fold. Yeah, just as an example. Or if you have some time-based in time series problems, it's oftentimes very difficult to have a proper CV setup, because you always have leaks in the sense of that the training fold leaks to the CV fold, and then you might have some overstatement or understatement. So, but that's very important, because that tells you something usually about the nature of the problem and what you can also expect from private leaderboard, and how to go a bit into the direction to also do well on private leaderboard. But I think in a nutshell, it's about correlation to public leaderboard, conceptual correlation to private leaderboard. I mean, you can think about that and try to think if this will correlate, and not trying to overfit to your CV setup, because that can also happen. Like if you do let's say you do some optimization on the blending weights and you overstate your CV, and which might be also problematic.
Which will lead to a shake-up, as the Kaggle community calls it.
Yeah.
To talk more about your current team, if you could also tell the story behind the team name, The Zoo. You've used it on multiple competitions, and if you could tell us more about your team. And all of your amazing results have been in a team setup. So why do you decide to team up and your team for this competition?
Yeah, as I mentioned before, we started at work, and at work we have some cloud setup that we work in, and we have virtual machines in there, and all of them are named by animals.
Okay.
So that's why we decided, and we have on our wall in the office, we have kind of the pictures of the animals that we named the machines at, and the IP addresses and whatnot.
That's very interesting.
Yeah, that's why we decided, oh, it might be a cool name to call us the zoo, because we're kind of the zoo of all those machines. That's how the original idea was born. It has other implications actually that we only figure out afterwards, because I mean there is this notion of the model zoo in deep learning and in machine learning. We have like different models, and it's called model zoo. We try to diversify a lot in competitions, like doing different things and not focusing on one thing, like doing NLPs, computer vision, structural data, and so on. So it kind of also fits there because we have to work with a lot of different types of models. Yeah, that's a bit of the backstory. And then we kind of stick to it because it worked out in the first competition. Yeah, actually now in NFL, Dimitri got mad when 5 minutes we were not called the zoo, so I had to quickly change that.
I'll maybe try using that name and see if that gets me a gold medal, maybe.
Yeah. No, I mean, yeah. Sometimes it's cool to stick to something. It also builds a bit of the brand, right? People know us as the zoo, and yeah. Why we team up? I mean, it's usually Dimitri. He is called Dot on Kaggle, and me. As I said, we work together, we collaborate really well together. It always worked out. I still have to do a solo competition for a final gold medal. But teaming is so much fun to me. And it's also, I try to team a lot because that's a different kind of learning, I think, on Kaggle, is that you can learn from other people how they approach problems.
One of the grandmasters actually said that it's one of the most underrated things of Kaggle teaming up.
Yeah. Like in our second competition, we teamed up with Giba, who is like top competitor.
The competitor.
Yeah, exactly. Like we learn stuff there. Then we team up with other people. We teamed up with Christoph aka Dieter recently, learn new things. So I think this is really underappreciated. And this is another way of learning, because you can learn how people approach problems, and you can learn how they solve problems and how they think, and then try to incorporate it into your work. And also usually it's really beneficial if you have some kind of different opinions and different viewpoints. And so it has been always really valuable, and it's also fun, really fun to me to work with others. Yeah, but at one point I have to do a solo competition, or plenty of them until I will get the gold medal. But at this point in time, it's still fun to me to collaborate. So,
got it. How does your workflow look like in a team situation? So how do you track your ideas? How do you distribute your work? And how do you track all the experiments and the results and also the ideas?
We have a Slack channel. For example, we have some cloud storage, as mentioned before, for storing results. We usually set some Google Sheet up to track experiments and write it down. This is something I try to explore, or we try to explore at the moment, how to improve that. So, for example, trying out some tools like how is it called, weights and biases or something like that. We try some stuff out there. Maybe something sticks, maybe not. To try to optimize the experiment tracking a bit. For now, it's usually talking about it in Slack, having a Google Sheet or some kind of sheet where we track experiments, write down CV, write down LB, write down what this experiment was doing. We try to also visualize that. We try to talk a lot. Maybe if you ever team with me, I'm a very, very talkative person in Slack. Sometimes people don't reply to me for hours, and I'm just doing a monologue. But I'm rather a person who I like to communicate ideas quickly, even if they don't make sense. And that's also nice in a team, because others can pick it up, think about it, and then either you neglect it or you follow up on it. Sometimes also, like, if it might happen that someone is on the road for a week or so, has an idea, posts it to Slack, and someone else can quickly pick it up and try it out. So talking a lot is, I think, another really interesting thing about teaming. And we try to diversify, of course, things. It depends a bit on how much time we have in the competition, how much we diversify. But for example, in the previous competition, we tried to split up quite a lot of things. So Christoph was doing more neural networks. We were doing, I was responsible for blending. So one person is responsible for blending. I was responsible for fitting cat boost models and light GBM models. Dimitri was mostly focusing on feature engineering and getting the user IDs we will talk about, also doing hyperparameter tuning. Eric was also in more in feature engineering, and Max also in neural networks. So we tried to split it up a bit. It's nice if all people are on a similar level, because then you can really split it up. Yeah, sometimes it's also not so easy to coordinate if you have more people. And I think now the limit is anyways 5. It was 8 before sometimes.
Yes.
But it's also a different learning. Like, it's how to work in a team, how to split things. As said before, people try to forget that there is more than learning how to fit the light GBM model, and more different things you can try to pick up from working in such an environment.
You mentioned all of these tasks. How do you decide which task which person will take up? Is that a natural flow, or do you actually do a call and divide the work?
We discuss it usually on Slack just. I mean, a few things are really natural. Like, I haven't seen a competition where, for example, not fitting a bit of different models is important, or where blending or stacking is not important. So those are usually things that you can split up. Like, it doesn't make sense that 5 people work on blending if it's something you have out of the box anyways in your scripts, and you just try to think about how to properly do it, and then someone does it regularly. Because, for example, the workflow is, you work during the day, and then at night you start with, you run one blend, sub it, and the next day you work on some models, then you blend it, sub it, and so on. So it's kind of a natural flow there. For other things, of course, you need to discuss and decide on who does what, and how to split up things. It's always not everyone has same amount of time. So, I mean, so someone has more time at the moment, and that person tries to do more, hopefully. The others can be a bit more occupied with other stuff.
Got it.
I mean, one thing in teaming is to me important, is maybe as a suggestion to others. It's, you don't need to have time all the time. It's rather being honest about when you have time. Like, telling people in advance, I will be on vacation, and this week is already enough that people can plan around it and try to set things up.
That's really great advice. Finally, if you could talk more about maybe a high-level overview, because it might be too technical, of your gold-winning solution of the competition, and the decision-making process behind what led to you picking the architectures and the decisions.
As I mentioned, the task was to predict credit card fraud on a single transaction. As it turns, and Kaggle provided us with a lot of features, and also a lot of features that were handcrafted already by the hosting research institute or company. So they had some from in their house built features that they provided us.
Okay.
One major thing in this competition was that it was possible to identify a customer in the data. So one customer makes multiple transactions, and then you try to identify which transaction belongs to which customer.
Right.
They did not provide us with the customer IDs directly, which I find a bit, would have been better maybe to provide it.
Okay.
So people spend, I guess, at least 50% of the time of the whole competition to reverse engineer those user IDs, those customer IDs. And that was very, very crucial, because you can think of, if you have a customer with 1,000 transactions, it's natural that that customer at least has majority have the same kind of fraud or not fraud. So it helps a lot. If you have some kind of notion of a customer, you can also build aggregate features of that customer. You can think of other ways. So I think that was maybe the most crucial part, to figure that out, and then to get well-working user IDs. Because then you can add this as a feature, or you can do aggregate features, and that helps
Makes sense.
Yeah. We started doing it. We started to team up as 4 people, and we had some decently working user IDs. But then we merged with Eric, who had some better IDs, and then it really helped us because then we could fine-tune the user IDs and fine-tune the handcrafting. Dimitri and Eric did most of the work there. It was really like some complicated things like figuring out which feature of Vesta, which is the company, means what. So for example, the cumulative sum of previous transactions over the last 90 days, and then try to make sense out of that, how you can reverse engineer the user IDs.
Got it.
As within most tabular competitions in the past, there was, to me, it is kind of some data leak or however you want to call it. So at least it was some kind of puzzle you needed to solve to do well here. Right. Thankfully, at least, the user IDs did not overlap that much to test data, which means that in test data, of course, you can still identify customers, but you can identify a much less or lower number of customers that you also have in train.
Okay.
So the impact of having those customers is still crucial, but it's not as heavy as in training data.
Got it.
And also in public leaderboard data, because public leaderboard was time-wise closer to the training data than the private test data.
Okay.
This is something we figured out. This is also, you have to think a bit, why is the public leaderboard score lower than your training CV score generally? This makes sense because you have a larger time gap, you have lower overlap to training data, and then you can try to think, oh, in private, this will be even more the case. So that led us to not only develop models that work well for these customer IDs and overlapping customer IDs, but also try to develop models that work well on new customers that you have never seen before.
Mm-hmm.
So that's kind of, we split this problem into 2 parts. We try to find models that work well on these, what we call overlapping parts, so customers that we have in test data that we also know from training data. So you can call it known customers, and for unknown customers which come newly to the system and which we have never seen before. I think personally, I don't know it. I think the business value is higher for the unknown customers than for the known customers.
Yeah, I would think so.
Yeah, I would imagine. I was asking on Kaggle, the competition hosts, what really the business goal was. No one answered, but some like CPMP will have winners call. Maybe they can figure out what was really the case. I think that sometimes, just a little side step, I think that's sometimes a bit missing on Kaggle, that hosts don't communicate what they really want to do with the model, because then maybe people would focus a bit more. I mean, you still try to win, but at least people would maybe try to figure a bit more what the hosts really want. Anyways, so we had 2 types of models. We knew in test data which part is a known customer and which is an unknown customer, at least roughly from our roughly calculated user IDs. And then we blended different models for those different 2 parts together and kind of just put them together. And that's our solution in a very rough nutshell. We used different models. We used light GBM models. We used cat boost models. We used neural networks. Those were the 3 types of models we used. And for those 2 different parts, we use, for example, neural networks, we only use for unknown customers and not for known customers, and cat boost only for known customers and not unknown customers. Okay. So it was kind of the thing was to think about how to properly set up the CV, how this will translate to leaderboard, and how the private leaderboard will look like. Usually what we try to do is that you have 2 submissions. We try to do one more stable submission with a robust blend. And usually we try to do one submission which is more a gamble, based off what we think maybe the private leaderboard will be. Okay. In this competition, the more robust solution of us was better. But the gamble was not too different. Yeah. So we just tried to We just tried to even improve the unknown customer part a bit more because we expected it to be more unknown customers in test, but it didn't play that much of a role.
Okay. Has that been the case for the gamble submission in all of your previous experiences as well, or has the definitive one been a better score?
Mostly it's the more robust submission that is better. In this competition now, we did the robust submission as kind of, we couldn't decide on all of our top blends we had, so we just took the top 7 blends or something and just again blended them together to one single thing. So we couldn't decide, so we just took, it's kind of robust because you combine, and usually the better working single models then kind of boost the score of the blend up anyways, so it's kind of a robust thing. In the past, I think the gamble worked definitely in earthquake prediction, where we got first place, where we did a gamble of trying to sample the training data based on how the test data looks like.
Okay.
But there I think we even had 2 gamble submissions because we had the advantage of being low enough on public leaderboard so that we could justify doing 2 gamble submissions, but still one was more gamble, and I think the more gamble one was better, but I don't remember. Otherwise, I think it was mostly the robust one.
Interesting. There's a common prevailing sentiment as well that you need an absolute huge amount of compute power to win Kaggle competitions. Can you confirm or deny that? And what would you recommend to someone who's looking at bagging medals on Kaggle competitions?
I think it depends on the competition. If it's a GPU competition like NLP, like computer vision, it definitely plays a large role.
Especially the Google and the YouTube ones.
Exactly. I mean, I just wanted to say, look at the Google competitions. You have 200, 300 competitors, 4 of them at the same time. And it's basically now with the new GPU requirements specifically, or limitations on Kaggle, it's basically impossible. Another thing that people sometimes try to forget, it's not only about fitting the model once, but it's also about experimenting. Like if I join a computer vision or any type of competition, I want to run during night, during day, a lot of kernels that try out different ideas, that try out hyperparameter tuning, that try out whatever. And then if you're limited by the resources, that's a big role because you cannot explore as many ways in your development of the models as you would like to do. So for example, sometimes we set up some hyperparameter tuning kernel, fork that 10 times and just run it overnight 10 times. If you have more team members, you can do that even more. And now with CPU, it still works. I mean, you have 2 cores per kernel. It's not perfect, but you can still partly do it. 4 cores, right? But in GPU, it's basically impossible nowadays. I mean, you have 30 hours per week. Which sometimes you need to run one kernel 8-9 hours, and then you can do 3 experiments per week, which is hard. I personally have a machine at home. I have not a fancy machine. I have one GPU RTX 280 Ti, not much, but it allows me to at least do the more simple computer vision experiments and stuff at home. Others use cloud platforms. I mean, there are people on Kaggle who have access to some large clusters, and of course, naturally, this has some advantages. You still need to do your work. It's not like just having the computing power is enough to do well. But I mean, it definitely helps because you can just start it and let it run, and you don't need to sit always change manually and then restart. So I think it has advantages.
What would you envision in terms of advice to someone who has a good amount of money to invest in setting up a machine? What would be your suggestion to them? What machine should they look at?
I personally, I have always been a huge fan of cloud. Nowadays, I'm more leaning towards building something yourself. I mean, both things are nice, but actually cloud costs are not that cheap if you want to do still a lot of experiments and fitting. It really depends, but I would stick to some customer, like normal customer GPUs from NVIDIA, I guess. So some RTX 280 Ti or something, maybe get one or two. Get some AMD processor on top, so either some Ryzen or some Threadripper, and then build something your own. It's also something, I mean, it always was also a bit of my hobby to do hardware and building my own rig. And so for me, it's fun. For others, it might not be that fun. And of course, you have to pay for electricity. You always need to think about that. The thing runs mostly the whole time, so it has disadvantages definitely. But I guess there are a lot of blogs and a lot of resources out there to figure out how to properly do it. I kind of like it. It works out for me.
I'd like to drop a plug. So I actually interviewed Tim Detmers, who has one of the best blog posts in terms of recommendations. So follow.
Yeah. I think I followed that even when I was building mine. Yeah.
So if you're interested, do check out the interview with Tim Detmers as well.
I will definitely.
In hindsight, I'm sure many of the experiments for this competition and broadly also would have failed. So you run a lot of experiments, many do not make it. Do you investigate that as well? And any thoughts on why didn't those work?
Sorry, what do you mean again? What kind of experiments?
So while you modeling or running these experiments for the Kaggle competition, many don't deliver a result that you'd expect. So you'd expect a model to do well, but maybe it doesn't. Do you investigate that as well after the competition ends, maybe, and any such examples from this competition?
Well, the most important thing is, at least sometimes, or at least mostly if you have time, to try to think why it didn't work and then try to make sense out of it. Like, oh, I have a brilliant idea about doing some pre-processing, and then I do the pre-processing, and then the model works worse on CV and on LB. That happened to us much more frequently in, for example, the computer vision thing we were doing with retina disease, the Aptos competition. So, and then you try to, I mean, that's critical thinking, and that's also important to craft a good solution, is in order to understand why something went wrong. Or what frequently happens is, oh, this works well on CV and this works really bad on public leaderboard. And that's actually a good thing, because then you can really try to better understand how the test data looks like, and maybe also critically think about your CV setup, which might overstate something and so forth. There is not always time to explore everything. So of course, we try to also after competitions to make sense out of a few things by reading other solutions, by maybe trying out a few subs after the competition ended and trying to make sense of it. Yeah.
Got it. You're also, for the audience, I'd like to mention, you're also very active in the discussions. You're in the top 10 on Kaggle in the discussions tier. Why is that important to you? Why not just keep working on the competitions and go on a vacation after you win?
I mean, I got top in discussion by posting memes. So I don't think this is too valuable.
But there are also your discussion that I really learned from. So for example, your solutions, etc.
Yeah. As I mentioned, I liked always in research to write up my things, to do blog posts, to do papers. So it's kind of natural that I also try to do that here. We actually posted at least the description of our solution of every single competition, and I would hope, or I would encourage others to do so as well, because as we mentioned, this is something where other people can learn from, and it also gives you some critical responses sometimes, because, for example, someone might see your discussion and think, oh, we did it differently, maybe you should try out this next time, and so on. So it's also kind of valuable, and it gives yourself also kind of retrospective of what you have been doing, and a good summarization of what you have been doing. I think it would also make sense for people who are not top 10 to do some write-ups, because I think what oftentimes happens is that people who are not on top of the leaderboard still figure out very, very important things, and they cannot put it together maybe sometimes. Yeah, they cannot make quite full sense out of it. That sometimes happens that they post it during the competition, and then some other people make sense of it and put it together, and it gives a huge boost. So for example, in Santander competition that happened. But maybe there is other stuff out there that is not shared yet, and which someone might have figured out, or someone might contribute something to it. Also, post your questions, your solutions afterwards if you want to get feedback. I'm sure people are always to give feedback on your solution and maybe give hints of what to do better.
I definitely echo with that. So for the first competition I entered, which was the quick draw doodle challenge, I actually got into the top 35%, which for me wasn't bad at all. And I created a submission discussion, which was my first goal discussion as well, that these are the things that I did. This is how I approach the problem. Do you agree? Do you disagree? And all of the grandmasters actually jumped in there. They gave a lot of suggestions, which is what led me also to getting addicted to Kaggle. So definitely agree with you on that.
Yeah, definitely.
This has been an amazing collection of advices from you. For my final question, what would be your best advice, or maybe a few tips for someone who's just getting started on Kaggle and machine learning, broadly speaking?
Pick some problem, pick some competition, and just try to solve it to some degree of satisfaction. I mean, I always have learned the most if I do stuff myself and try to craft the solution myself. And so, because it's very important that you also get more fluent in what you're doing and don't need to think about every single step all the time, because then you can advance what you're doing and can also develop more robust solutions. So, I mean, I guess that's the standard advice. Kaggle is really perfect for that, and I love it for that, that it offers so many competitions that you can just jump in, and you can also do late submissions to competitions. So it even gives you a way to measure yourself without any pressure on previous competitions. Don't be afraid of anything. I mean, everyone starts out somewhere. Not everyone has a huge background in the area, and it gets more hyped area every day. And people try to jump in. And I think you can build your own a good portfolio, and it's important. What I really like is that you also delve into different types of topics. Don't focus on something. Try to be more diverse, because that might help you in different aspects of your professional career.
Makes sense. Before we end the call, could you maybe tell us what would be the best platforms to follow you and follow your work, apart from Kaggle?
Apart from Kaggle, I guess either LinkedIn or Twitter. My Twitter account is ph_singer, I think.
I'll have it linked in the description.
Yeah, perfect. So follow me there. That's it, I guess.
Okay. Thank you so much, Philipp, for all of your contributions to Kaggle and even the community. And best wishes to you for becoming a Grandmaster very soon.
Thank you. Thank you. Time flies by. 1 hour gone. Wow.
Thank you so much.
Thank you.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review, or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.